What's up, everybody? Welcome to Python 101 Collections, and today we're going to be covering lists, sets, and dictionaries. Today we're going to be working out of Jupyter Notebook. I have a couple code snippets here so you can follow along and participate. And I also have some explanations of some built-in functions we're going to cover as well. And so with that being said, let's get started. The first thing we're going to talk about are lists. So what are lists? Lists are ordered and mutable. And so what that means is lists will retain the order of the elements you have inside of them. And also the values can be changed within a list. So they can be swapped, they can be updated, or they can be removed. So mutable just means that it can be changed. And then lastly, lists are zero-based index. So what that means is if you had 1, 2, 3 in your list, and I said, get me the value at the 0 index, you would get back 1. Okay? So right here is just a little thing I want you to remember is lists are ordered and mutable and 0-based index, and the data types can be different. What we're going to do is we're going to build out our list. So if I said songs.append, and we're just going to do some artists. So we're going to put Beyonce, and then songs.append Miley Cyrus, and I print songs, we're going to get Beyonce, Miley Cyrus. And that's because append right here adds an element to the end of our list. So as you can see, I had append Beyonce first and then append Miley second. So that'd be 0 and 1. Now, let's say I didn't really want Miley on my list. I would say songs dot pop open close. And so we're going to use the default right here. And this is just going to say, take off the last added element, which is Miley. So when I print this now, I just get Beyonce back. And it's the same thing here if I were to change this to pop 1. We're going to take this one out here. I said pop 1. So we're specifying in that 1 index. So 0, 1 would be Miley. We're just going to keep Beyonce. And if I said pop 0 in that 0 index, the first person, I'm just going to get Miley back. So append and pop are pretty much your bread and butter. You'll pretty much use them almost everywhere. But let's keep moving forward to see some of the other built-ins. And so, same concept. Let's add some more people. Justin Bieber. So now we have Beyonce, Miley Cyrus, and Justin Bieber. And let's say we have 2 Beyoncés, right? So we have 2 Beyoncés now. And remember, you can have duplicates in a list. So if I said now, print songs, let me see Beyonce at the start, Beyonce at the end, and I just want to remove the first time I see Beyonce. So if I said songs.remove Beyonce, and let me print that out now, print songs, we're going to take out that first Beyonce found because remove is going to take out the first occurrence of an element. Now, we're going to switch songs over to some digits just to showcase what sorts, reverse, and count look like. And this is common, you'll see around on some leak code problems usually, or, working with coding challenges people give you. So we're just going to say songs for I in range 0 to 9, songs.append I. And so this will give us 0 through 8. So now, let's say it's already sorted. So we're not going to use sort right here. What we're going to use is reverse. So if I said songs.reverse, and I print songs, it's going to give me song backwards. So remember, we were going 0 to 8. Now we're going 8 to 0. So reverse is a very useful one when you just need a quick reversal of your list. You can do it with numbers. Commonly, that's what you're going to use it for. Typically with strings, it gets a little bit more complex, and there may have to be some conversions used for that. but that's more advanced. We'll probably cover, bit conversions and alphanumeric conversions later on down the road. This is purely just to be comfortable with the built-in functions and the types of data structures. And then so sort would do that same thing. It would just reverse it back to 0 through 8. And then count is a very fun one. So if you're looking for the amount of occurrences of an element, you would use count. So we have 0 through 8, and we're gonna append 3, dot append 3. And so now we should have 3 threes. And so if I said songs, print songs dot count, we're gonna count 3, we should get back 3. Because now we'll have 3 threes within this. So let me print songs up here so you can see that as well. So you have 1, 3 in the 0, 1, 2, 3 in the third index. And then in the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The, wait, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9th and the 10th index. I was right. Sometimes you have to count these things out loud. And then lastly, we're going to try out extends. And so we're going to bring back the songs. So I'm going to reverse all the way back to before this. And we're going to go back to our default songs. And we're going to have numbers equals this. And we're going to create numbers. And so now what we're going to do is do extend. So this is going to add all the elements from another list to the end of our first one mentioned. And so in this one, we're going to start with songs as our baseline list. So we're going to say songs dot extend numbers. And numbers has 0 through 8. And then we're going to print songs out. And so what it did here is it took numbers, which had 0 through 8, and it just added it to the end of our songs list. And so that's just used if you want to add something on to the end of something. And then lastly, we have clear, and this is just going to empty out your list. So if I said songs.clear, print songs, emptied out. And so those are some built-in functions for your list, and one of the most common data types, data structures you'll be using. And now let's take a look at our next one, which will be sets. Sets are a little bit different from lists because sets are unordered, but they are still mutable. And so if we access any item within a set, there's no consistent order, so we can't rely on their indexes always being the same, like a list. Okay, but a unique benefit of a set is there can't be any duplicates. And so you can't have 2 1s, 2 2s. There can only be one of each value within a set. So these are very good for membership tests. So when you're using the N keyword and you're searching for something, this may be your go-to if you only want unique values. And then once again, they can store different data types within the set. And so we have our built-in functions we're going to cover up here. And then let's see what that looks like. And we're going to use numbers. So to start out, we have the set called numbers. And sets you're going to use the open and close parentheses for to instantiate it. And then it is surrounded by curly brackets right here. You can see little curly bracket. Now, right now in numbers, we have 1, 2, 3, and 4. Okay. And so instead of using append, sets traditionally we use add. And so this is going to add it to our set. And so if I said numbers dot add 6, and then we print numbers, we're going to add 6 to the end of that. But once again, you can only have one of each value. So if I said numbers add 6 here, and I said numbers dot add 6 again, and I print it, it's not going to add it again because it already knows we added a 6 above that line. Now, we're going to refresh this. and back to just 1, 2, 3, 4. And we're going to use remove. And so this is, once again, just going to remove a specific element within our data structure. So numbers.remove 3, print numbers, and we just have 1, 2, 4. And then we're going to do discard, which is the same as remove. So discard 4 this time, and we will get 1, 2, 3. So discard and remove, very similar. And then also we can still use pop, numbers.pop. We're just going to get 2, 3, 4 instead of 1, 2, 3, 4. And so if I do numbers pop and I try to put in 2, it's not going to work because it doesn't take any arguments, because remember, it is not ordered. So there is no specific way to say get this index within the set. We have to specify the value because there are no duplicates. And then lastly is update. So if you want to add another set to it, so let's say letters equals set, and we say letters dot add A, letters dot add B, and we said numbers dot update letters, and print numbers. We're going to get A, 1, 2, 3, 4, B. And this is a perfect example of it not being ordered, because we would never know where we're going to have A and B from letters end up at, right? Meanwhile, if we use the list and we did extend, we knew it would be at the very end. So it went 1, 2, 3, 4, A, B. And then lastly, what we're going to do is we're going to do numbers dot clear, and we're going to print numbers. And just to show it again, we're going to print numbers right above that. And there we go. It's emptied out. So these are the built-ins we covered today. Remember, sets are mutable, they are unordered, and they cannot contain duplicate values. Last but not least, and probably the most important one to memorize, are dictionaries. And so dictionaries are ordered and mutable, just like lists, except for we have key pair values now. And so what this means is we assign a key which will reference to get a value, kind of like variables. However, we do not allow duplicate keys. And so typically when you see a dictionary, you're going to see these in a JSON format, and it's short for JavaScript Object Notation. And the cool thing about dictionaries is you can access these values through the keys in an O of 1 space-time complexity. And if you're learning computer science, it's kind of just like saying, how fast can I access something? And that's really important when you get later on in your career about optimizing things for performance or speed, or how much memory you're taking up, and whatever algorithm or whatever your program is doing. So keep that in the back of your head, and just remember, dictionaries are key pair values. And so let's look at what that looks like. And so to create your dictionary, we're going to have students equals DICT with an open and closing parenthesis. And this is just a standard way to instantiate a dictionary. And so for this example, I have 3 students I created with their own little profiles. So we have John, Emily, and Frank. And within this, we have 4 keys. So we have grade, GPA, graduating, and classes. Okay. And so now to access the profiles of these students, what we're going to do is we're going to print students.get, and then we're going to look at John's profile. And so what we're doing is we're going into the dictionary, which has 3 keys on the top level of John, Emily, and Frank. And we're accessing John by using the get built-in. And that gives us access to all of the key value pairs listed under his profile. So grade, GPA, graduating, and his classes. And you can have any data type within these. And so we have a number, we have a float, we have a Boolean, and we also have a list in there. Now, there are 2 ways you can get this information. So you can do it this way with .get, Or you could say print students and then do a bracket, and you could do it like that. It's the same way. However, very important to memorize this, try to use the dot get instead of the brackets. And the reason behind this is that when you use dot get, if it doesn't exist, it returns none. But if you use the brackets and it doesn't exist, you'll get a key error. And so that's just saying that key doesn't exist. So let's take a look at what that looks like. So if I put Johnny, and we're gonna take this line out for now, we're gonna get back none because Johnny doesn't exist. But if I put get Johnny with the brackets, we're gonna get that key error because it doesn't exist. So very important, remember that about dictionaries. Now let's move on to some of the other built-ins. And so let's look at items. And so items is just gonna give back all the items within the dictionary. So this is useful if you want to see what's in there and what key value pairs line up. So we're gonna do print students dot items. So you can see the dictionary items stored inside of a list of key pair values. So we have John here, we have Emily, and then we have Frank. So this is just giving us all our information back and what it should look like. Next, we'll look at the values built in. So it's going to give us all the values that's stored. So very similar, except for now you don't see John, Emily, and Frank because these are our overhead keys, right? So now we just see the grade, the GPA, the graduating, and the classes. So these are just the values. So there's no keys. So items will give you both. Values will just give you the values. And then lastly, if we do dot keys, we're just getting our keys back. Okay. And then let's also take a look at removing a key. So we have John, Emily, and Frank, and say, I don't want Frank in there no more. Frank has graduated. If I say Dell students, and I'd say Frank, and then I print students again. Let me do students.keys to make this a little bit cleaner. Frank is now removed. So if you need to remove someone, Del is the way to go. And then lastly, if we want to look at pop, this is very similar to the way it works in lists. So let's go here and we're going to print students.pop and we're going to pop out Emily. And so what that's doing is it's going to remove Emily, but pop is also going to return the values of Emily. So let's do it up here first. Not pop Emily. Open close. And students dot keys. We'll just have John and Frank. There we go. So pop is similar to del, except it will remove the value, but it will return the value as well. So there's key distinctions on that. If you need that value returned to you and you want to take it out, you'll use pop. If you just want to take it out and you don't need it back, use del. And that's a wrap on everything. Hopefully you learned something new. Thank you for watching, and this has been Python 101 Collections.